Hello guys, this is Jacob. So AI Coder is getting very popular, and today in this video, I'm gonna show you one of the popular options. It's called Aider. So how to set Aider with the open source LLM, which is Ollama, and how to run Ollama on a remote free GPU on Kaggle with Cater. So hopefully this is interesting. Um, let's get started. So if you go to Aider.chat, so you'll see a lot of the introduction documentation, all the LM it supports, and includes OpenAI, Anthropic, Gemini, Grok, Ollama, DeepSeek, and OpenRouter, so on and so on. And if you go to Ollama section, you can see the setup is very straightforward. If you want to set up Aider with Ollama, it basically just needs to export Ollama API base. So if you look at documentation, it's 123.001. So this is actually a local Ollama instance, but this requires a GPU on a local laptop or a local PC. So that actually limits a lot of the usage. So in this video, I'm going to show you how to actually tie this Ollama to a remote GPU instance on Kaggle um, that you can just run the Aider remotely, which is a lot more convenient. And the model we're going to use is the Llama 3.2 just released. So then you don't have to use the 70B model, which is require a lot of the VRAM. So that being said, let's go to Kaggle. So first, we just create a notebook. It's called a Ollama FastAPI because we need two pieces in the Ollama backend service that we're creating. The first is the Ollama service that just runs Ollama, and to use the GPU and expose the GPU to the public, we also need a backend, a RESTful service. So that RESTful service we're gonna build with the Fast API. So with these two components, you can basically just wire up Ollama and with the GPU and expose this to public. So so let's continue. So we have to first, as usual, we create a Python function that can run a bash command within the Kaggle notebook. So we just create a run function here. Then we install Ollama, so just one line command, and then we just spin up Ollama. So this is a first component. So that should be set up Ollama within the Kaggle notebook. So and then we just pull the Llama 3.2 um, LLM, which is just released. So this by default is Llama 3.2 3B. And so this is a very advanced and economic LLM. So you can just do Ollama pull. So Ollama already supports the Llama 3.2 version. Then if you want to set up supervisor, you can do that. But in this tutorial, I can skip the supervisor. We just put it here for demonstration purpose. So then we just jump to the Ollama list. So you can just check if Ollama has the Llama 3.2 installed by just running Ollama list. So and in this case, it is installed. So it is we installed Ollama 3.2, and then we have to install the dependencies that you build the RESTful service. So we have to install the FastAPI UVcorn request Ollama and async.io and OpenAI. So we install these dependencies. And the one of the most important dependencies is also SAC solid. So this is for streaming as a RESTful Python service. So we have to install that. This is required for to run the Python RESTful service on Kaggle. So um, and then we have to create a main.py to basically build the RESTful service. So we just write a new file. It's called a main.py, and then we just add some references, which is Ollama async.io, and we also have to include the typings generator and a dictionary list, so on and so forth. And we of course we have to include the FastAPI package. So and in the SSE Starlet, we have to include the event source response. So this is for the streaming piece. So we'll show that in a bit. And then, so this code is not perfect. This is for demonstrate purpose how this can be done. So then we create an endpoint. It is called a stream endpoint. It's a get call. So to create a fake endpoint, so this you can just test if the streaming works. So just create a very simple async function streaming data and return a streaming response. And call a streaming function called generate data. We're just streaming this 1 to 10 digits using this one stream. And then we do a sleep for half a 0.5 second, and then we return as our event source response. So with the media type as text event stream, so this will basically stream basically this string data chunk as a, a 0.5 second interval. So you can use this function, test it out, and then we just create another function. It's called a chat with the post method and has a generic path. So this will allow any client, and not just Adder, to call this endpoint. So because every client has a different way to wire up the LLM, Adder and Cloud App, and also the other like continual adapt, they all have very different ways to call it. So this allow to debug which endpoint is calling and what payload is actually using. So this payload is very generic. It's a dictionary, so it captures basically anything that that client AI assistant client is calling. So we use that to actually make all the client AI assistant to fall to this block. And then we create a generic data. So this is a streaming function. In this Adder case, we dump the payload to see what Adder client is basically calling Ollama for, right? And then we get the model name and messages from the payload. And this is basically the prompt. So if some of the client AI assistant client is using the chat endpoint instead of generate, and we also want to use the messages array. In this case, we just use message. But in case some of you are using the cloud app, right, is using the V1 chat completion, which is OpenAI endpoint. So you might want to actually use the this piece of code to add that prompt to the messages and pass it in to Ollama compatible OpenAI compatible API. Or if you're using OpenAPI, then you might want to actually capture the messages in this way. And then we basically just using the Ollama generate for the Adder assistant. So we just pass in the model we capture from the the payload, and get the prompt also from the payload. We set streaming to true, and we get the stream. So after that's completed, and we just run the for loop to get every chunk in the stream is to see if the response is valid, and then we just do a JSON dump so that we'll get a string from the chunk, and then we yield that JSON string. So um, and then we basically um, get the generate data as a streaming function and pass it into event source response and get the media type as a text event stream. So this is completing the streaming RESTful service wrapper for Ollama. So that's it. So we can skip the rest of the two test endpoint. So this for Cloud Dev. The other is also another test point. We can skip that for the Adder usage case. So, and then we're gonna expose this RESTful Python endpoint to public. So we need to install Ngrok. You can install Ngrok in two ways. One is for the binary, but we're gonna use the pip install. So pip install py ngrok and ngrok, and then basically we can get the Ngrok token from the Ngrok console. We can register a free account on Ngrok and get authentication token and paste it in here. So we because the service is running on 8,000, if you go back to this piece of the code, we spin up Unicorn on 8,000. So we expose that to public using Ngrok. We expose it using localhost 8,000, and then we basically push it to public as using this address. So this randomly generated Ngrok public address, and then it points to a local host. So That's it. So that's for the Ngrok setup. Then we just spin up the main.app, the RESTful service. So basically using the file name as main. So it's main.py, so it's main.app. So we just spin up. So you can see this is actually running on 8000 and this is public. So just go to this address. So this is all the setup you need for the Kaggle notebook to actually expose the Ollama to public with the GPU. So you can see this is actually already spin up. So next, in this tutorial, we're going to go to the Visual Studio to see how that works. So let's go to the Visual Studio Code. And all we have to do, you can just do a test file. So this test file is gonna basically use the public endpoint, public domain we just created, and we just simply do a prompt, give me 10 sentences, and with Apple, and use the model, the Llama 3.2. So then we just do a curl command, very straightforward to test if the endpoint is live and working. So to do that, we just go to we just do the code terminal, and we basically just do a test.sh. You can see actually this is streaming, right? So the streaming piece works. So and then we're gonna use Aider to actually call this new endpoint. So if you just export Ollama base API base to the new endpoint we created, so you can just paste in the public domain and then just hit enter, and then we just simply export this Ollama API base, and then just do Aider the model. We use Ollama, and we just use Llama 3.2. If you want to open this in browser, you can do that as well. We'll demo that a bit, but now we just do the terminal version. So you can do Ada model and wire up the Llama 3.2 model. Just enter. You can see this is actually working, and then because Llama 3.2 is just released, so it's not in the default um, Aider Ollama support list yet. So we can basically just say, okay, skip this check. All right, so just skip it, proceed, yes. And then it will actually just call the Llama 3.0 model. And so what we need to do is let's go back to some of the demo prompt that's on Aider offshore website to test it out. So let's go back to Aider's offshore website. Let's get the usage, go to the usage section, go to the chat modes. So there are a lot of samples you can test out. So the first one, I will just test out this code feature, right? Add a function to calculate the factorial of a number, right? We just copy it and go back to the Visual Studio Code terminal, and we just paste it in here, and then see how that works. So you can see it starts writing, right? And let's implement the new functionality. Before we start, so we can actually try that again. Let's say standalone function, or maybe you can just do that again. So you can see it's actually starting, right? And then if you want to create a new file, I just click yes. So maybe you can try that again. Oh, it's actually created. Okay. So you can see this function is created, right? And I can do another try on a. Let's go back to the Aider Chats official website. Let's get another sample. Let's use the architectural model. So it's architect, feature, then let's say we use architecture to make it simpler, or we can just do something very uh, very funny, or maybe a little bit more complicated. Let's go back to the Visual Studio Code. Let's re-enter that again. So proceed anyway, yes. Okay, and then all we have to do is to make sure that we do architect, create a mind sweeper game using HTML, CS, and JS. Right, let's hit enter. So it's actually start thinking and producing. So edit the files, yes. Okay. Also, at the same time, I want to show you guys this is actually logging all these everything that the model produces. So let's go back to the Kaggle notebook while we're waiting for it generates the output. So go back to the Kaggle notebook. You can see if you go to the so I think there's a little bit memory increasing usage increase. So, but anyways, so you can actually check out the logs just within the notebook. So let's go back to the terminal. It's still generating. Well, this is actually still generating. I want to point out another thing. You have to make change for on the Aider client. So if you go to the utils, Aider utils.py, so basically there's a function called handle Ollama string because when you use the SSC started package and that event source class, basically the output from that streaming function, it has a data prefix to it. So instead of just a JSON string, it also attached a prefix is data dot something. So so you have to basically do a little bit processing so that you can actually um, just only takes the LLM's output. So to do that, it just do a regex, import regex, and then just take using regular expression to take the JSON, which is LM output out, and just put a bracket around it, and that's it. So that's the new, basically a chunk that can be loaded as JSON. So, but that's all you need to do. and then basically it's gonna load the chunk. The original output from the endpoint, uh, the original output basically it has a data, so that's why you have to do a very um, basically refactored so it can be JSON loaded. So I think the process is finished. Let's see. On the set, okay, so the game, the JS is completed, and then the HTML is completed as well for a minor sweeper game. Okay, all right. So let's go back to Kaggle. So you can see Kaggle has generated a lot of logs. So while we're actually processing on the Visual Studio code terminal, you can see there's a lot of logs. That's why the memory is a little bit overwhelmed, but it's okay. But you can see very in detail how Aider is calling the endpoint, so that you can get an idea of how Aider works. Okay, that being said, um, this is how you use Aider with Ollama on a remote free Kaggle GPU. And hopefully this video is helpful. And if you do like this video, please subscribe and comment or like. And thank you so much. And see you in the next one.